Okay, I'm trying to show you how to do our textbook question, chapter 6, question 18. So that's the 2 points. So select it randomly on a line of length L. And you know that the length is L. And the 2 points, the first one actually, say X is between L over 2 and 0. While y is somewhere on the second half. It's between L over 2 to L. The question now tells you that, oh, and also both of these are uniform. So the question asks you to get the probability that the distance between the 2 points is greater than L over 3. All right, so how to solve this problem? So first of all, we know that any event, say event of x and y, same time belongs to some group or some region. It's the double integral over this region, and you're integrating the joint density, okay? So this is what we know from class. So let's look at what is the joint density and what is the region over here, okay? So first of all, the density. You assume, the question tells you that they are uniformly distributed independently from each other. So by the independence, we know that the joint should be the product of the marginal. Okay? And the marginal, we know that x is uniform 0 to L over 2. So fx equals to 1 over L over 2 minus 0, which is L over 2 over L when x is between 0 and L over 2 and 0 otherwise. Okay. Similarly, y is uniform L over 2 to L. Okay, so fy will be 1 over L minus L over 2, which is 2 over L as well, when y is between L over 2 and L, and 0 otherwise. Okay, so you know that this is fx, this is fy. So the joint will be the product of these two, will be 4 over L squared. Okay, so this is the first piece of the information. And the second part is from where to where we're integrating this joint density. So that, I always suggest you try to sketch the region before you start. So let's look at this. What do you want? You want, because we want to get the event that y and x, the distance between these two is greater than L over 3. So if you translate that into mathematic form, so it's y minus x, which tells you the difference between these two. You want to integrate over, like you want this to be greater than L over 3. Okay, so if x is here, y is here, you want to get this to be more than L over 3. So this will be your region of the C over here that you're trying to integrate. So to sketch it out, okay, so this, if you rewrite it, will be y greater than x plus L over 3. Okay, so this is a linear function over here. The intercept is L over 3. So it's parallel to the y equals to x line. So because y needs to be greater than that, so it's going to be everything above this line. Okay, all right, so, but this is only part of the graph. What else do we need to restrict? We need to have x between L over 2 and 0, and y between L over 2 and L. So say this is L over 2, and this is L, and this is L over 2. So what do you need? You need to have 0, you need to have x between 0 and L over 2, and y is between this two, and plus y needs to be above this line. Okay? So if you draw this, you will realize that this is the region that you try to integrate over. So the problem over here becomes y greater than x plus L over 3, and then 4 over L squared dx dy. Okay? So how to move forward? This region, we draw it over, is what's on this graph at the moment. Let me use a different color. So the thing is, in double integral, if you have a region like this, a good practice is break this into 2 parts at least. So for example, so first of all, the reason why you should break it into 2 parts is if you look at like y goes from L over 2 to L, but once y goes from these 2 points, the region or like the bound for your x changes. So first of all is here, and then over here as well. So this actually tells you that you might to break it into 2 parts. So one way you can do it is to integrate this box and then this region separately. Okay, so what you're gonna do, if you do this one part first, then this still doesn't change. And then this one, so this point, if you solve it, you will realize it's L over 6 and L over 2, yeah, right? So this, the range of x is, so if I do dx first, it's gonna be 0 to L over 6, while for y, it's gonna be from L over 2 to L, okay? So this is the part 1, okay? And let me use a different color for 2. So for part 2, you still have the function, the joint, to be 4 over L2, L squared. And in this case, you might want to integrate, let's see, if you do dx dy, then if you do dx, you realize that you need to have it to be, because this is the line, so x should be smaller than y minus L over 3, okay? So your x should always be smaller than y minus L over 3, but greater than this point, right? Sorry, I think it's probably easier to do dy first. Sorry about that. So if you do dy over here, dx. So let me erase this part. So if you do dy, you'll realize that the range of your y is bounded below by this x plus L over 3 and bounded above by this line. Okay, so bounded by L. And then the range of x is gonna be from this point to this point. So that will be L over 6 to L over 2. Okay, so this is the second region. Okay, so both of this, the joint density is a constant, so you can move that out into your integration and then do the rest. Okay, so the final answer is 7 over 9, and the integral should be straightforward to do. Okay, all right, good luck.